All right, welcome everyone. We're here today to make fun of Connor Park. Yeah, yeah. Connor, you're not here, and we are just talking trash about you. And it's, I have to say, a lot of fun. So, these are some notes for section 4-4, and we're talking about translating periodic functions. And even though there are lots and lots of functions that are periodic, one that we always want to deal with is the sine function. Now, some of you skippers that skipped FST maybe haven't dealt with sine and cosine too much. Um, and so you'll be at a little bit of a disadvantage. You may want to review that or watch this video when you get home. We'll deal with sine and cosine and tangent and all their friends next semester, but we're also going to deal with it a little bit now simply because sine function is such a great periodic function. Sine function is mimicked in lots of ways in nature. The main one that you hear about all the time are tides. High tides and low tides, they're sinusoidal. Sinusoidal. That means they act like a sine function. Tides, also hours of daylight. Lots and lots and lots of others. And it just goes on and on. But these are two big ones that come to mind right away. Both sinusoidal functions, both go like this, on and on and on, forever, repeating. So we're going to talk about ways of transforming periodic functions today, and specifically the sine function, because we know it so well. So in the warm-up, we talked about... Claire, you doing okay? You miss Connor? She just said no. Man, Connor, that hurts. Boy, hit a guy when he's down. That's rough, Claire. Okay, so we talked about if you do y equals 2 sine x. And in the warm-up, we talked about this 2 controls amplitude. Amplitude. And so now instead of a maximum, a local max of 1, we're at a local max of 2. We still have our root at 180, and then we go down here to the t in amplitude, and then back there, back up. So then if we put a 2 coefficient in front of sine x, it's going to go like this. It's going to go down. It's going to go down there. It's going to go up, etc. And we'll continue. So that's a simple transformation, simply expanding it to be twice as high or twice as low. Now, that's the graphic version then looks like this. We take the axis of the graph, which may or may not be the x-axis, and Claire, we go the distance from here to here to get our amplitude. Okay, so that's 2. Or if you go here, it's also 2. It's not a negative 2, it's just a distance from that axis. Now, if you don't like to do things visually, you can also do things for amplitude with symbolic notation. And you can say, okay, the highest high, we can say y2 minus the lowest low, y sub 1, divided by 2. So in this case, what's our highest high? Daniel, what's the highest high we get to? 2. And what's the lowest low? Negative 2. Careful, negative 2. So we can go 2 minus a negative 2, watch your sign, divided by 2. And we get, I should move this over a little bit. What do we get, Sarah? Right? We have 2 minus negative 2. 4. There you go. So it's 4 over 2 equals 2. And so we come up with that same 2 that we got here. Now the only caution I will make on this, if you get a graph that is shifted up or down, if I get a graph that's shifted up here vertically, what happens to my axis? Yahira, what happens to my axis? Exactly. I got my graph that's shifted up 1 unit. What happens to my axis? This fuchsia line, or is that magenta? It shifts up 1 unit also. Exactly. Okay? So now, everything shifts up. My amplitude is still 2. Because it's from this axis of the graph, not the x-axis. Okay? And that's an important point. But if it shifts up here, you can still do it by saying, what's my highest high now? Gabino? What's my highest peak? 2.5 minus my lowest minus 1.5 over 2. You get the same thing, 2. So it doesn't change. So that's amplitude. Item next. Period. We've talked about that a little bit, and you guys obviously, and ladies and gentlemen, you all, I should say, that's gender neutral. You all have obviously had period before, because a lot of people were talking about peaks and troughs, and that is true. What a mess. I got to clean this up. So yeah, I'm going to get rid of this one too. So if you're looking at the period, again, we just say from the highest to the highest, how far is that? How long does it take to start over? Well, in this case, we're going from 450 to 90. You can say that's 450 minus 90 is 360 degrees from there to there. And you can pick anywhere. You know, you can go for the lows. You can go like here and say, okay, it starts over right here. I see where the pattern repeats itself. And that's just a period. Okay? Question on that? The last one, well, there's 2 more, I guess. We had one that was y equals sine x plus 90 degrees. And this is just like we did with parabolas. If you put a plus, what does it do to the parabola? No, inside the parentheses. It kicks it left or right. And if it's plus, which way is it, left or right? It's left. So if we go like this, plus 90, it's going to kick everything left 90 degrees. But everything else is the same. The period's the same. The amplitude's the same. It just shifts it. It just shifts it. Okay? Questions on that? And the last one we had was, I'm going to move this out of here. Get down, get down. Doesn't want to go away. The last one we had was, let me think. Oh, up, I know. Where we went sine x plus 3. Let's go minus 3 here because I'm running out of room. Claire, you doing okay? Minus 3. Okay, and again, this one vertically shifts down 1, 2, 3 units and would just look like that. Everything else is the same. Everything else is the same. And that, ladies and gentlemen, is the story of transformations. And this is an intro because What happens when you put a bunch of them together? They start to get harder to look at. They start to get harder to look at because then you get things like y equals 3 sine, x plus 90 minus 3. I should go 2, just to be different. You start to get ones like this, and they're definitely more involved. But we won't deal with those yet. This will really be next semester, something to look forward to. Okay? Any questions? Let's see how we did on time. Oh, 10 and a half minutes. We're under 11, Connor. So get well. We miss you, and we hope you come back soon. That is all. See ya. Yeah.